Hey everybody, just a quick video to give you a few more hints. All right, layer A here is a basalt intrusion. That means it is igneous, right? So this is an igneous rock that had to cut through these layers, but then lay down flat on top of this layer, okay? So think about what would have to happen for this to cut through those and lay down on top here, right? Could B have existed before A? Right? Did D have to exist for A to cut through it and lay down on top? So that's a hint I'm going to give you. A is a basalt intrusion. All these other layers are sedimentary. Okay? Also note that they are no longer going to be in alphabetical order. The first one had the layers in alphabetical order to try to help you. Okay? Here again, looking at the rock layer types, B is a basalt intrusion. You can see here that there are some stars which show that that basalt heated up the rock next to it and changed it, right? But there are no stars here. Also notice an unconformity here. So remember what an unconformity means? Rise up, erode down, and subside again, okay? So keep those things in mind that in order to put these sedimentary rocks on top of this weird boundary, that weird boundary had to be created, eroded, and subsided before C, D, and A were laid down on top. Okay? All of this practice is for Thursday when this really, really, really big and complex one you'll have to do. I put on the next page a big picture of this one. Okay? So a few hints I'm going to give you here. So rock layer C is a basalt intrusion. So this intrusion, you can see there's a little bit of it there. This intrusion cut through D, H, and A, but it did not cut through F, I, and B. So all this stuff down here had to happen before all this stuff up here, okay? So try to resolve this area before you resolve this area. Notice also that this basalt intrusion happened, and then later this fault happened. So this fault had to happen after the basalt intrusion. Notice also that all these things got wavy before the basalt intrusion cut through them and before the fault line cut through them. Okay? So think about how to lay these layers down flat, how to make them wavy, how to cut through them, and then how to fault them. All right? Then F, I, and B happened, right? But they had to happen horizontally, and then they got tilted. Okay? Then they had to be eroded so that E could be laid down flat on top. All right, I think that's enough hints for that one. And then the last thing you have to do is write a short history of the geology of the area on the previous slide. So what tectonic forces could cause folding? What surface features could cause sedimentary rocks to form? What tectonic forces can cause a fault or an igneous intrusion? Try your hand at writing a geologic history of slide 10. This video is a very detailed story of just a single rock. Okay, you do not need to go into that much detail, but what I like about the video is it shows you um, what sorts of forces can cause different things to happen, right? Two continental plates coming together causes something in the video, right? Or being below sea level causes something to happen in the video, right? So here, as you think about D, H, and A being laid down, you could start by talking about this area was beneath a shallow sea. Okay, when it was beneath a shallow sea, these things happened. Okay, then the area right slid over a hot spot, and that hot spot caused this igneous intrusion to happen. Okay, so just giving a general idea of what had to happen for these different things to happen. Okay, so think about what geologic forces, pushing, pulling, hotspots, and all the different plate tectonic stuff that we talked about, what would happen for this whole picture to come into view? All right, we'll talk more during the Zoom about it, but hopefully that helps.